Welcome back. This is the last lesson on electron structures of atoms. Uh, it's a video lesson number 3, and we are going to cover valence electrons, group numbers, Lewis structures, valency of atoms. So, in group 1, we've got hydrogen with its one electron in the 1s orbital. It is in period 1, that's why its electron is in the 1s orbital. We have lithium with its 3 electrons, and you'll notice that the valence electron is in the 2s orbital because it's in period 2. The element is in period 2. Next element is sodium with 11 electrons, but sodium's got one valence electron in the 3s orbital. Last element is potassium that we look at is potassium, and potassium's got 19 electrons, but it's got one electron in the 4s orbital. Now, what is the same in all the group 1 elements? Group 1 elements have one valence electron. So what is important about the valence electrons? The importance is it's the one electron that is involved in bond formation. So this would be chemical bonds. So the number of electrons that determines, for the metals especially, that determines the bonds is 1. Each of these can form one bond. So we say that this one bond is the valency of the element. So group 1 elements have one valence electron that can form a chemical bond, so its valency is 1. The Lewis dot diagrams or Lewis diagrams uses a dot or a cross to represent the valence electron. Now, a cross is easier to see than some people's dots will be so small that I can't see them properly. That's why I prefer the cross. Lithium's Lewis diagram would be also one with a cross. Sodium's dot diagram or Lewis diagram has one valence electron. Potassium has one valence electron. I hope this helps. Watch it with the other videos and it will become clearer for you. If we look at the group 2 elements, we will see that each one of the group 2 elements will have 2 valence electrons. This is beryllium in the second period, so to energy level 2 will have beryllium's 2s orbital. This is magnesium with in period 3, so the valence electrons are in energy level 3, and this is calcium with its 2 valence electrons in energy level 4. So this is beryllium, with 4 electrons but only 2 valence electrons. So the Lewis diagram for beryllium, not boron, beryllium will have 2 crosses because the valence electrons are the ones that will be involved in chemical bonding. Those are the electrons that we are wanting to focus on. Magnesium has 12 electrons, of which 2 of them would be valence electrons. So magnesium has 2 crosses in its Lewis diagram to show the 2 valence electrons. Last one that we're looking at in group 2 is calcium. Calcium's got 20 electrons. The 2 valence electrons are in the 4th energy level. So we see a pattern here in group 2 elements. Group 2 elements have 2 valence electrons that are involved in chemical bonding. So the valency, which is the number of bonds that these elements can form, is 2. So lots of 2's for the elements in group 2. In group 13, now I teach my students to, just for the sake of this, cover the 10 because that will help them to see the 3's. So in group 13 we have this is boron. So boron has 3 valence electrons. This is aluminium. Aluminium's got 3 valence electrons. So boron altogether has 5 electrons, but only 3 of them are valence electrons. Now I draw 2 together because they are in the 2s orbital. So these would represent the 2s orbital, and this one would represent the electron in the 2p orbital. That's why it is drawn alone. And this element is aluminium with its 13 electrons, but only 3 of the electrons are valence electrons. So we can say that group 13 has 3 valence electrons that can be forming chemical bonds. Because there are 3 valence electrons that can form chemical bonds, the valency is 3. Right, group 14 elements, I teach my children to cover the 1 of the 14. Then you'll see that there is a correspondence between group 14 elements, and that is that they've got 4 valence electrons. So it's 4 valence electrons for the elements in group 14. So this would be carbon with its 6 electrons, but only 4 of those electrons are free to form chemical bonds. Now, they have learnt that carbon does something very special, and carbon shares 4 electrons separately. So for carbon, for the group 14 elements, we're allowed to draw the 4 bonding electrons alone. The same for silicon. Silicon's got 14 electrons, but only 4 of them are valence electrons. and silicon and carbon will behave in a similar way. You may draw the Lewis dot diagram like this, where 2 electrons are together and 2 are separate, but this first way is also correct. So we see, to conclude, in group 14, there are 4 valence electrons that makes 4 bonds. So the valency is 4. Group 15, now the ball game changes, because these groups contain mostly non-metal atoms. So the non-metals tend to share electrons, and they can only share electrons when there's a half-filled orbital. In group 15, it's the nitrogen group, you see that the elements have 5 valence electrons. So this is nitrogen with its 7 electrons, but only 5 valence electrons. And you see that 2 of them are together and 3 of them are separate. This is the phosphorus atom with its 15 electrons, but only 5 of them are valence electrons. You can see in the 3s orbital there will be 2, 1, 1, 1 in 3p orbitals. So to conclude here, group 15 elements has 5 valence electrons, but only 3 to share. So the ball game has changed when we get to group 15, so there are only 3 is the valency, the number of bonds that these elements can form. Next, group 16, we see that group 16 elements has 6 valence electron. That's oxygen, and this is sulfur. So oxygen, although it's got 8 electrons, and sulfur's got 10 plus 6 is 16 electrons, the oxygen will only have 6 valence electrons. And you can see 2 together in the s orbital, 2 in a p orbital, 1 alone in a p orbital, and another one alone in a p orbital. The same applies to the sulfur. Elements in a group are alike. So we can see that we have 6 valence electrons, but only 2 to share in a bond. So the valency is 2. Lastly, we go to group 17 elements, and we see that they have 7 valence electrons. The first one is fluorine. It's got 9 electrons. Next one, chlorine. It's got 17 electrons, but only 7 of them will be valence electrons. And you see that there are 3 pairs and 1 alone. 3 pairs and 1 alone. So although you have 7 valence electrons, you have only 1 to share, so the valency is 1. Group 18, you can see that the valence electrons are full, all the orbitals are full, so they can't form bonds. So the conclusion is the following.